In this video, we will be demonstrating that you cannot easily inspect ferromagnetic materials with eddy current testing. The reason is because materials with magnetic properties, or materials that have permeability, tend to concentrate the eddy currents at the surface of the material, having extreme skin effect, and you don't get any eddy current depth of penetration, so you can't inspect through the tube wall, and you certainly won't see anything on the outside of the tube. The only chance we have of seeing anything in this cal tube are maybe the 100% hole, if there's any ID flaws in there, but like those ODs, for sure we won't. So anyway, let's just test it out. We're going to test it at a range of frequencies. I'm starting off really low. You would think that a low frequency would penetrate well through the material, but let's just check it out. So we'll null that at 1 kilohertz. Now I'm just about out of the standard right there, and as I pull back, that's a tube support. No, it's not a tube support either. What the heck is that? I want to turn it around. That way I can be sure where there's a tube support. Null. That's the tube support. And then as I pull through the rest of the standard, I'm not seeing much of anything. So let's try taking frequency 1 up to like 100 kilohertz. Let's see what that does. Come on now, there we go. Null. Erase. Erase one more time. Now when I come back, the first thing I should see would be the support plate. There's your support plate. And then I'm pulling past the 420s. Nothing. About the 40, 60, 80, 100. And then towards the end, let me erase so you can see. Towards the end, I get that big signal. Well, that's an ID groove on the inside of the tube. And since we have extreme skin effect because of the ferromagnetic material, there are a lot of eddy currents at the inside surface of the tube. And that's expected. Now, the reason you get a tube support plate signal on the other end, I'm going to pull past it again. Right there, that thing right there. The reason we get that is because the tube support ring on the outside of the tube is ferromagnetic. It's made out of carbon steel. And anytime you have carbon steel close to a magnetic field, it's going to almost rob that magnetic field from wherever it comes from. So it really tends to concentrate the magnetic field through the support. So you can see the support plate, but you can't see anything in the tube unless it's on the ID. So now let's increase. Let's just go to like 500 kilohertz. We'll go 500 kilohertz, see what that does. So I'm going to go up just about out of the tube and hit null, and then erase. There's your tube support plate. Now we're going to go past the 420s, 40, 60, 80, 100's in there somewhere. And then you get the ID groove right there. And I didn't even bother setting phase on these. But that's all you see is the tube support and the ID groove. And then just for fun, we'll go up to 1 megahertz and see if we see any difference. So I'm going to push the probe almost the whole way out. I'm going to hit balance. Tube support plate. The 420s. Oh, you hit erase. 40, 60, 80, 100. And the ID groove. And out of the standard. So whether we're testing at 1 kilohertz, 100 kilohertz, 500 kilohertz, 1 megahertz, it is not fruitful at all we cannot find anything in the Cal standard other than the ID groove, because the tube material is ferromagnetic. That's why eddy current testing is limited to non-ferritic materials. Thanks for watching the video. I hope you learned something.